Hey folks, welcome to the channel. Today, let's discuss bubble sort. So basically, there are various sorting algorithms and bubble sort is one of them. So given an array of elements, so for example, so let's say there is an array. So given an array of elements, there are various ways you can sort this particular array. So one is ascending order and one is descending order. So to achieve this ascending or descending order, so there are various sorting algorithms that you can apply, and bubble sort is one of them. So the reason why it is called as bubble sort is because it basically compares adjacent elements, and if the adjacent element is greater than the next element, it basically swaps and moves that element until the end of the array, hence the name bubble sort. So basically it's like bubbling up the elements one after the another. So the key things that we have to remember in a bubble sort is it compares adjacent elements and it swaps the elements. So these are the two key criteria for bubble sort. So it compares the adjacent element and swaps it up. So let's consider this particular array for the bubble sort that I'm going to explain, and let's see what happens. So during the first pass, what basically happens is the first two adjacent elements gets compared. Because 5 is greater than 1, it gets swapped in the next iteration. So the new array is 1, 5, 4, 2, 8. So again, the adjacent elements gets compared, which is 5 and 4. Because 5 is greater than 4, these two get swapped in the next iteration. And here, as we can see, the new array is 1, 4, 5, 2, 8. And here the adjacent elements are compared again, which is 5 and 2. Because 5 is greater than 2, it gets swapped. And in the final check, the 5 and 8 is compared. Because 8 is already greater, the swap does not happen. So as you can see from the first pass itself, the reason for this algorithm being called as bubble sort is because it is bubbling up the element 5 to the top of the array and it stops just before 8 because 5 is lesser than 8. So let's see what happens in the next pass. So as you can see from the first pass, we have 1, 2, 1, 4, 2, 5, 8. And during the second pass, what basically happens is the last element is not going to be checked because it's already sorted. So the first two elements are compared and 4 is greater than 1. So nothing gets swapped. And again, 4 and 2 gets checked. Because 4 is greater than 2, these two get swapped. And during the next pass or during the next iteration, because 5 is already greater than 4, the swapping does not happen and the comparison stops here. During the third pass, what basically happens is it checks the first and second adjacent elements. Because 2 is greater than 1, nothing happens. And it compares 2 and 4 because 2 is lesser than 4 or 4 is already greater than 2. So there is no swapping that happens and it stops because the last two elements are already sorted. Then we have the final pass wherein which only the starting adjacent elements are compared. Because this is already sorted, so there is no swapping which happens, and these three elements are ignored because these three are already sorted during the previous pass. So what we can derive from this basically is there are n minus 1 passes which happens for an array elements of size 5, it will be 4 passes. So this is something that we have to remember. So for bubble sort, so there are always n minus 1 passes that happen. So let us understand the bubble sort using the Java code. So basically here I am declaring an integer array of 5 elements 5, 1, 4, 2, 8, and I am going to explain with this example of bubble sort. So basically we need two loops. One is the outer loop, one is the inner loop. So the outer loop is needed for the number of passes that we saw in the last example, where in which for this particular example, so there are 4 passes which runs, hence n minus 1, the length of the array is 5 and 5 minus 1 is 4. Hence we need a outer loop for the passes, and inner loop is required for adjacent element comparison. So here, as you can see, it travels from 0 to n minus 1, which is the length of the array. But on every pass, it will ignore the sorted element. So basically, during the first pass, it will be 0. So hence, it will not ignore anything. And from subsequent passes, it will start ignoring these indexes because these are already sorted. And here, as you can see, this is where the comparison is actually happening. So basically it is checking first element and second element. If it is greater, it is going to call the swap function. If it is not greater, it does not go inside the if statement. So for every pass, it is going to go through this code, compare, swap, and repeat until all the elements are sorted. So one thing that we have to see here is we are going to compare j and j plus 1. So this will help us in comparing the adjacent elements. Hence j and j plus 1. And it will travel from 0 to the length of the array, but it will ignore the sorted elements on each pass. So these are the two criteria that we have to remember while implementing the bubble sort: the adjacency matrix or the adjacency comparison, and the swapping of elements if the element is smaller or the element is greater than the target. So the time complexity of the bubble sort is n square because worst case it has to traverse all the elements, hence it is n square. And the space complexity is O of 1 because we are not using additional space, it's only a single array, hence the space complexity is O of 1, and the time complexity of worst case is n square. So yeah, thank you for tuning in. Please add below if you have any comments, or let me know which algorithm I should cover next. Thank you.